Hello, Chaya. Hello. Am I audible? So I'll wait for 2 more minutes and then I'll start if anyone joins. Hello, Chaya. Am I audible? Okay. Okay, we'll wait for 2 more minutes. Then we'll start. So is my screen visible? Okay. So we'll start. Good evening and welcome to the week 2 live session of the course Waste to Energy Conversion, instructed by Professor P. Mandal from IIT Roorkee. I am one of the TA for this course. I am a PhD scholar in Civil Engineering Department at IIT Kanpur. So basically what we will do is I will give you a brief recap of what was covered in week 2 lectures. Then we will go through assignment 2, previous year assignment 2. Then we will solve 2 questions based on tutorial on incineration, and then we will wrap up. So, uh, First lecture of week 2 was on incineration. There were two lectures on incineration, and then there was a tutorial, and one was on gasification. So what happens in incineration is that we burn the waste in presence of excess oxygen. Basically, we use air to provide oxygen. There is a very two benefits of incineration. First is that through incineration, there is a large reduction in volume of the solid waste. Through incineration, there is reduction in 90 to 95% of the waste volume. And second, the heat which is generated by combustion can be used to generate energy by running the turbines. So basically what happens in combustion is that any biomass or waste which is composed of carbon, it is burned in presence of air to produce carbon dioxide, water vapor and heat. Other byproducts will also be formed depending upon the composition of the municipal solid waste. So for complete combustion, because if incomplete combustion will take place, then we will get less amount of heat because some amount of biomass or waste will not be combusted, and we will also get lots of pollutants in the flue gas. So for complete combustion to take place, we require four things: time, turbulence, temperature, and fuel to air ratio. So whatever air to fuel ratio is, we provide air in excess of that so that complete combustion takes place. For complete combustion, air to fuel ratio should be proper and the time for combustion should be optimal. It should not be like that the time provided for combustion is less than the time required for complete combustion of the waste. There should be proper turbulence so that there is proper entry of air in the solid waste for the combustion to take place. And there should be proper temperature for the waste to be burned. So what happens in combustion? It takes place in three mechanisms. Takes place first is by providing the heat, the water vapor present in the municipal solid waste, it escapes. So there is first step is drying. Then in the second step, whatever volatiles is present in the waste, that comes out of the waste and that is pyrolysis. And then finally in third step, what happens that whatever volatile gas and whatever char is left, that is burned and then we get the flue gas. Next is air requirement. Obviously, we require oxygen to burn any material, and that is provided through atmospheric air. So here we can see that suppose this is the composition of any municipal solid waste that is composed of carbon, hydrogen, nitrogen, sulfur, oxygen, and these are A, B, C, D, E, F represents. So these represents the number of moles of these elements in the municipal solid waste composition. So for burning this composition, we require G moles of oxygen. And what for the products which will be formed? Okay, some people are joining, so I'll wait for one more minute. Okay, shall I start now? Are you guys having problem in joining. So please anyone confirm if I am audible, because I'm seeing that Mukesh and Uma Devi are struggling to connect. You can write in the chat, Mukesh or Uma Devi, please confirm if I am audible to you. Please anyone in chat. Please any one of you confirm if I'm audible to you or not. Okay, so I'm starting now. It's already 7:15. I'm restarting from slide 1, and I request you all to please join on time. It is from 7 to 9 p.m. on every Sunday. So welcome to the NPTEL course of Waste to Energy Conversion, instructed by Professor P. Mondal. I am one of the TAs for this course. I am a PhD scholar in Civil Engineering Department at IIT Roorkee. So what we will do is that we will start with a brief recap of what was taught in week 2 material. Then we will solve previous year assignment question. And then we will try to solve 2 to 3 questions based on the tutorial on incineration. So first, okay. First, incineration. Basically, incineration is burning of anything in presence of excess oxygen. So what happens in incineration is that we burn the waste solid waste in presence of air or oxygen, and the end product we get is carbon dioxide, water vapor, heat plus other byproducts based on the composition of the waste. So in incineration, there is a large reduction in volume of the waste. There is about 90 to 95% reduction in waste. So if we have 100 kg of solid waste, then after incineration, we will get 5 to 10 kg of ash only, and rest will be burned out. So the heat which is produced during incineration can be used to produce energy. By running turbine, we can get electricity. So for complete combustion is required, because what happens if complete combustion is not taking place, then the energy from the incineration will not be proper, and also there will be lots of pollutants. Like if complete combustion is not taking place, then we may get carbon monoxide in place of carbon dioxide, and carbon monoxide is poisonous. So for complete combustion, proper fuel to air ratio should be present. The general trend is that we provide excess air for complete combustion to take place, and proper time should be provided for the solid waste to burn. There should be proper turbulence so that there is a mixing and the air is entering in the solid waste, and there is proper temperature for the waste to burn. So time, turbulence, temperature, as well as fuel to air ratio is required for the complete combustion to take place. So next, in combustion, 3 mechanism takes place. First is drying. When the temperature is increased, whatever water is present in the waste, that escapes from the waste, and then whatever the volatiles are present, that escapes from the waste and produce carbon dioxide or carbon monoxide and other products. And then finally, what happens, the volatile gases as well as the solid which is present after escaping of the volatiles, these are burned in presence of oxygen, in presence of excess air or oxygen, and we get the end products. So air requirement, how we'll calculate the air requirement for incineration? So basically we'll find how much oxygen is required, and on the basis of composition of air, ratio of oxygen to nitrogen, we will find the requirement of air. Suppose we are given the composition of municipal solid waste is CaHP NCSTOE plus ash. Quantity of ash is F. A, B, C, D, E, F represents percentage or mass of these elements present in the municipal solid waste. So for burning 1 mole of this gas, suppose we require G moles of oxygen. The end product we will get is carbon dioxide, nitrogen, NO2, SO2, water, and ash. By equating A, B, C, D, E, F, by equating like for carbon, if there is A moles of carbon in the reactant side, then there should be A moles of carbon in the product side also. So from this we will get A equals to H. Similarly, we will do mass balance for B, that for B moles of hydrogen, the number of moles of hydrogen on the product side should be equal, that is B is equals to 2I. And we will equate for nitrogen, sulfur, oxygen. We will get number of equations, we will solve them, and we can get the values of A, B, C, D, E, F, and we can also get the value of G from these. So basically the trend is that about 5 to 50% excess air is provided for the complete combustion to take place. So for increasing the efficiency, combustion is done in stage. Like air staging can be done and fuel staging can be done. In air staging, we provide air in stages. Like primary air is provided, then secondary air is provided for burning of the volatiles. In fuel staging, we add the fuel in stages in the incinerator. So the benefits is that there is good mixing because their fuel is also added in steps and air is also added in step. There is less excess air required because there is a cost associated to the supply of air also. The cost will be cut down and the efficiency will also improve by using air staging or fuel staging. Next, we will see what are the advantages and disadvantages of combustion. Obviously, air pollution will be one of the disadvantage because lots of pollutants like SO2, NO2 and other organic pollutants will be there in flue gas, and that should be first extracted out from the flue gas. Then flue gas should be allowed to escape in the atmosphere. Second disadvantage is the fuel quality varies because there may be chances that the municipal solid waste or the solid waste may vary in composition. So we will have different waste on different days. So next is risk of fire and CO poisoning. Obviously, we are burning the solid waste in incinerator. So there is a chance of fire and also carbon monoxide poisoning if incomplete combustion is taking place. We know that carbon monoxide is very poisonous for humans as well as other creature. Next is like we need to, as I told you, we need to monitor the temperature, time, turbulence. So lot of monitoring and maintenance is required. Also, we need a lot of storage for storing the solid waste and various pre-treatments are required. So we need space for that. So what are the advantages is that it is a low cost technology, but it is very reliable. Like we are putting the waste, combusting it and the energy we will get, and this is a quite reliable source for getting energy from waste. The process of incineration is well established and almost 97% of the bioenergy is extracted through the process of incineration. Next, we need to provide some pre-treatment to the waste. First is sorting. We need to sort the waste on the basis of their size. Then we need to homogenize it. The homogeneous mixture is made and then it is added to the incinerator. Then shredding. If the size of waste is very large, then we need shredders to reduce their size. So there are two types of incinerator reactors used. First is fixed bed and next is fluidized bed. In fixed bed, waste is spread on waste is spread and it is burned in presence of air. But what happens in fluidized bed that some bed material is used like sand and waste is added, and through air velocity of the air, the sand as well as waste are in continuous motion. So there is burning of the waste as well as movement of the waste along with the air. Obviously, the fluidized bed reactor is more efficient as compared to fixed bed reactors. So next is there are two types of FBR. Okay, I can see that people are having problem because they are joining and they are leaving. I think they are having connectivity issues. Okay, anyhow, this will be provided to you all. If you are having connectivity issues, just log out and then rejoin. That will help you. So there are two types of FBR. First is bubbling fluidized bed and second is circulating fluidized bed. So the difference is that the air velocity in circulating fluidized bed is more than the air velocity in bubbling fluidized bed. Since the velocity of air is high in circulating fluidized bed, so there is chance that the waste is not burned properly, and also the sand and waste may come out along with the flue gas. So what happens in circulating fluidized bed that the sand and unburned waste are extracted from flue gas and these are recirculated to circulating reactor and it is reburned. So obviously there is certain advantages of using fluidized bed reactor as compared to fixed bed reactor for incineration. First is fluidized bed is suitable for high moisture fuel or low grade fuel. If the moisture is more in fluidized if the moisture is high in solid waste, then we can use fluidized bed reactor. Next is operating temperature are lower than fixed bed system. Next is higher combustion efficiency in fluidized bed reactors, and last is most suitable for large scale operations. Next, we'll see environmental aspects of combustion or incineration. Obviously, there will be air pollution issues. There may be NOx. Their NOx control system will be required to control the NOx emission into the atmosphere. Next is there may be mercury or dioxins present in the flue gas, which we need to first remove. Then there may be acid gas removal required because of the SO2 present. Sulfuric acid may form and we need to remove it. And lastly, particulate matter removal. So there are two problems associated with incineration. First is slagging. Due to presence of alkali and acid in the solid waste, we face problem of slagging and corrosion of boiler tubing and erosion of refractories. Next is gasification. So in incineration, we provide ample air for combustion to take place. But in gasification, we provide controlled amount of oxygen. So what happens in gasification is carbon compounds are converted into combustible gas, which is commonly known as syngas. And this syngas is further burned to get energy from it. So if in gasification, generally we provide 35% of oxygen demand. If suppose for complete conversion, we require 100 grams of oxygen, but for gasification, we will provide only 35 grams of oxygen. And the end product we will get is syngas if oxygen is used for burning, and producer gas if air is used for burning. If air is used, then we will have nitrogen in the end product and it is known as producer gas. Next is, this is a table showing oxygen requirement. So, and whether the process will be combustion, gasification or pyrolysis. So R is the ratio of oxygen to the coal ratio. So if R is greater than 2.5, then it will be combustion. And if R is within 0.68 to 2.5, it is gasification. And if R is less than 0.8, it will be pyrolysis. We can see that R values is decreasing, that is oxygen content is decreasing. So it is going from combustion to gasification and then pyrolysis. So here is a brief in what are the chemical reactions taking place in gasification. What happens? Carbon react with oxygen. It may form carbon monoxide. These are the delta H zeros and delta H naught, in a heat of formation of these compounds. Carbon may react with oxygen to form carbon dioxide. Carbon may react with carbon dioxide to form carbon monoxide. And carbon may react with hydrogen to form methane, then so on. So next is comparison of gasification product gases. Like if we are using oxygen, then we will get syngas, and if we are using air, then we'll get producer gas. So we can see that the typical heating value of syngas is more than the producer gas. It is obvious because we are using pure oxygen in case of syngas. So the end product will have higher calorific value than the producer gas. So in syngas, the hydrogen content is 20 to 30%, but in producer gas, it is 13 to 19%. Carbon monoxide content in syngas is 40 to 60%, and in producer gas, it is 18 to 22%. Then carbon dioxide content is 5 to 15%. In producer gas, it is 9 to 12%. One thing which we have to see is that nitrogen content. The percentage of nitrogen in syngas is very less because we are using oxygen for burning. But in producer gas, we are getting 45 to 55% of nitrogen because we are using air for burning. Next, this is the reaction which is taking place. Suppose we have any waste, feedstock. First, we have to heat it. Then we will get two things, char and volatiles. Char is the solid matter, and volatile will escape into the, will come into gaseous form. So char and volatiles are gasified, and that is gasification of these two takes place, and we get the syngas. So here it is, a reaction is written just like incineration. Suppose we have a compound of suppose we have a volatile compound composed of carbon and hydrogen. So end product will be hydrogen gas plus carbon monoxide. We can balance this equation and we can get how many moles of oxygen is required, how many moles of hydrogen will be produced, and how many moles of carbon monoxide will be produced. So it is the next reaction is for char gasification. Suppose we have the char made of carbon, hydrogen, oxygen. From balancing this reaction also, we will get the number of moles of water, hydrogen, and carbon monoxide. Next is the steps involved in gasification. Here the solid waste is fed, then due to rise in temperature, drying takes place, then pyrolysis, then reduction, oxidation, and what we get is ash, and as well as the syngas or producer gas is obtained. So here it is written like, unlike incineration, in gasification, the volatile gas are not burnt completely. Rather, it is converted into a form which can be further used to get energy. Next is factors influencing gasification. Obviously, the feed type will very much determine what will be the end product, like what will be the composition of the solid waste. Next is gasification agent use. If we are using air, we will get producer gas, which will have high content of nitrogen, but lower calorific value. But if we are using oxygen for gasification, then we will get syngas, and its heat content will be more. Next, what is the temperature range and what is the type of heating we are using? And finally, what is the pressure under which the gasifier is operated? So there are certain advantages of gasification. First is there is reduced CO2 emissions because we are converting the organic matter into some form of gas which we can further um, use for getting energy. We are not completely burning the material, so CO2 emissions will be obviously less. Next is compact equipment requirement and the overall footprint like area requirement, size of the reactor are less in gasification, so it has a lesser footprint. The combustion control in gasification is better and there is high thermal efficiency. Like in incinerators, there were two types. Here, there are three types of gasifiers: fixed bed, and drain bed, and fluidized bed. So, again, I can see that there are only three people. So, we'll start with previous year questions. I request everyone to just type their answers in the chat box. And if you don't know the answer, no problem. Whatever you think is correct, you just type it in the chat box and we will proceed. So, first question is identify the figure given below. I'm sorry. So, this is the figure. Ignore this one right now. So, what does this figure signifies? It is rotary kiln, ball mill, or dryer. Please type your answers in the chat box. Okay. The correct answer is A, that is rotary kiln. What happens? This is a drum. It rotates. We add the solid waste from here, left corner, and this drum is rotating and there is a slight inclination. So the waste goes through this inclination and air is here the fire is provided. So what happens that waste is flowing in this direction and burning is taking place this direction and whatever the exhaust gas will come out from here and we will get the ash or whatever will be left we will get from the bottom right hand. So it is a rotary kiln, not ball mill or dryer. So next question is current sequence of biomass based incineration process. So you have to find out what are the sequence of incineration process taking place. So just write your answers in the chat box. So correct answer is A. First drying takes place because of the heat, whatever moisture is present in the solid waste, it escapes, drying takes place. Then there is pyrolysis, whatever volatile material is present in the waste that escape from the solid and comes into the gaseous phase. Then their reduction take place. Then whatever combustible combustion of volatiles and whatever char that is a solid material is left that is burned. So correct answer is A. So I'll move to next question. What is the range of excess air requirement for effective combustion of water and biomass? Just write your answers in the chat box. So correct answer is B. Generally 5 to 50% excess air is provided for the combustion to take place. So next question. Gasification of the biomass and waste converts its organic part into combustible by interaction with oxygen and steam so as to obtain a secondary gaseous fuel of high calorific values having no ash. Gasification reaction in fluidized bed gasifiers are normally carried out at about dash temperature. Basically, we have to determine what is the temperature range. Just write your answers. Or you can unmute yourself and you can say whatever the answer is. So the correct answer is B. The temperature is generally in between 900 to 1200 degrees centigrade. Next is a question based on grate. Which grate resembles stair with alternating fixed or moving grate sections? A. The roller grate, the rotricle, the reciprocating grate, and or D. None of the above. Write your answers in the chat box, or you can just unmute yourself and speak whatever you think is correct. No, the correct answer is C, the reciprocating grate. And this one grate is fixed and it is basically in the shape of stairs, and in which one is fixed and the other grate moves. So the correct answer is the reciprocating grate. Next is, what is the value of R, that is oxygen to coal ratio, for gasification processes? A, R between 0.68 to 2.5, or R less than 0.1, or R less than 0.68, or R greater than 3.5. Just write your answers in the chat box. So correct answer is A. are between 0.68 to 2.5. I've also shown in the slides, like you can see. For R greater than 2.5, it is combustion, and between 0.68 to 2.5, it is gasification. So, correct answer here is A. The next question, if air is used in place of oxygen in gasification process, the produced gas is known as syngas, coke oven gas, producer gas, or Kober gas. Just write your answers in the chat box. I'm getting only one answer, one or two answer, and there are three people. Please, everyone try to participate and write your answers in the chat box. No, correct answer is C. As I told you in the slides, if oxygen is used for gasification, then the product is known as syngas. And if air is being used, then the gas produced is known as producer gas. In producer gas, the content of nitrogen will be very high as compared to syngas, and calorific value of syngas will be more than the producer gas. So correct answer is C. We'll move to next question. It is a numerical based on week 1 material on COD test. So the question is, COD analysis of a wastewater sample is carried out through chemical method using 0.1 normal potassium dichromate solution as reducing agent. That is, oxidant here is potassium dichromate. Excess dichromate is titrated against ferrous ammonium sulfate, and the titrant we are using is FAS. 200 ml of wastewater sample is used. The volume of sample we have taken is 200 ml. The titer values of FAS are 60 ml and 85 ml for original sample and blank sample. So what happens that 60 ml of FAS is used for titrating the sample and 85 ml is used for titrating the blank. So we have to determine the COD of the sample. Assume there is no interfering element in the sample. I will give you I will give you 2 minutes to solve this question because it is a pretty straightforward question. You have to just use the formula for COD. So I'll give you 2 minutes. Just solve it and write your answer in the chat box. So I got one answer. Mukesh and Venkatesan, are you solving? Should I wait for 1 more minute?
No, I'm solved 100 milligram per liter.
Okay. Okay. So the correct answer is B, 100 milligrams per liter. So we will see the formula. So we can find COD by is equal to 8,000 into P. P is the volume of FAS used to titrate blank, minus S, where S is the volume of FAS used to titrate the sample, into N, where N shows the normality of FAS used, divided by whatever the sample volume we have taken. So here the volume of wastewater is 200 ml. The volume of titrant FAS for wastewater is 60 ml and volume of titrant for blank is 85 ml. And normality is 0.1. So it will be COD will be B, that is 85 minus S, 60 into 0.1 into 8,000 divided by volume of wastewater 200. We will get 100 milligrams per liter as COD of the sample. So we'll move to next question. It is a numerical based on bomb calorimeter. There was one numerical based on this concept in week 1 also. And one question was discussed in the previous week live session also. So I hope you will be able to solve it. The question is to determine the water equivalent of a bomb calorimeter. 1 gram benzoic acid sample was used. The experiment produced a net corrected temperature rise of 5 degrees centigrade. So temperature rise is 5 degrees centigrade. The acid titration required 12.5 ml of standard alkali and 8 centimeter of par 45C10 nickel chromium fused wire was consumed in the firing. Determine the water equivalent of the bomb calorimeter. So in the previous week question, water equivalent was given. We were finding the gross heating value. But in this question, we have to find the water equivalent of the bomb calorimeter. So I will give you the concept and I will give you the what formula we'll be using, and then I will describe what is M, E1, E2, E3. So water equivalent is equal to Hg, that is the gross heating value, into M. M is the mass of the sample, plus E1, E2, E3. These are the energy equivalents divided by delta T, that is the rise in temperature. So basically, this question is based on the values of E1, E2, E3. If we get these three values correct, then we will get the correct value of W. So I'll give you 3 minutes to solve this question. You just solve it and write your answer in the chat box. So I got only one reply. Chaya and Mukesh, are you solving? Okay. So I will give you the solution. So first we'll find what is even. Even is correction for heat of formation of nitric acid in calories. It is equals to C1 calories. So this is the standard 0.0709 normal sodium carbonate is used for acid titration. Here, acid titration, it is directly given the acid. No, the correct answer is B. So here the acid titration requires 12.5 ml of standard alkali. Standard alkali is this 0.0709 sodium carbonate. So even is equal to C1. Directly we are getting even equals to C1, that is 12.5. Next we have to find E2. E2 is correction in calories for heat of formation of sulfuric acid. Here E2 will be 0 because we are for finding the water equivalent, we are using 1 gram benzoic acid sample. So there will not be any sulfur. So E2 will be 0. And finally, E3 is correction in calories for heat of combustion of fuse wire. So here it is 2.3 into C3 calories. Where C3, oh, so here Hg is 8500 calories per gram. Mass is 1 gram. C1 will be 12.5. C2 is 0 and C3 is 8 centimeter. Because here it is given 8 centimeter of this wire is used. C3 is the centimeter of wires used for firing. So we will get E1 equals to 12.5 into 1. It is 12.5 calories. E2 will be 0 because C2 is 0. And E3 is 2.3 into C3, that is 2.3 into 8, 18.4 calories. We will put this value here. 8500 into this divided by rise in temperature is given as 5 degrees centigrade. We will get 1706 calories per degree centigrade. So correct answer is B. So I want to ask Mukesh and Chaya, what you were doing wrong in this question? Like, if were you able to find E1, E2, and E3? Mukesh, can you tell me what you were doing wrong? Okay, calculation problem. But you are able to crack now what will be E1, E2, and E3? Saya, can you tell me what issues you are facing? Like, were you doing a calculation mistake or you were having trouble in finding what is E1, E2, or E3? Saya, are you there? Saya is not responding, so we'll move forward. So basically in this question, we have to figure out what is E1, E2, and E3. If we are getting correct values of these three, then we will get correct value for W or whatever it will be asking. Like in this question, it is asking about the water equivalent. Suppose the question is up for finding the gross heating value. Then also we have to find out E1, E2, and E3. If these three are correct, we'll get the correct value. So we'll move to next question. It is based on the hemicellulose and extractive content. So the question is 3 gram of a dried agricultural waste is leached with benzene and ethanol mixture of 2:1 at 60 degrees centigrade for 3 hours. After leaching, the residue is dried in hot air oven at 105 degrees centigrade to a constant weight of 1.6 gram. This dried material is put into a flask containing 150 ml of N/2 NOS solution. The mixture is boiled for 3.5 hours with recycled distilled water. After this, the residue is washed with distilled water till all the sodium ions are removed and dried at a constant weight of 1.3 grams. Determine the extractive and hemicellulose content of this waste as a dry basis. Basically, we have to find what is the content of extractive and hemicellulose in the waste. We have to find the percentages of these two. So I will give you 3 minutes to solve this question. You just solve and write your answer in the chat box. So I got only one answer. Mukesh, you are correct. Answer is A. So we'll see first how to find extractive and hemicellulose. So for extractive, dried sample is leached. First dried sample is taken. It is M0 in grams. It is leached with ethanol mixture at certain temperature and then it is dried in oven at 105 degrees centigrade and it is weighted. So the initial dried weight is M0 and the weight after leaching and drying, oven drying is M1. So the percentage of extractive is given as M0 minus M1 upon M0 into 100. So we'll see in this question, M0 is 3 grams. It is given 3 gram of dried agriculture waste is used. M1 is 1.6 gram. It is written that after leaching, the residue is dried and to a constant weight of 1.6 grams. So M1 is 1.6. So extractive content will be 3 minus 1.6 into 100 upon 3. It is 46.66%. And for hemicellulose, what we do is that the dried sample after leaching, that is M1 is taken, it is put into a flask, and then 150, it is put into a flask containing 150 ml NaOH solution, and then it is boiled for some time, 3.5 hours at certain temperature, and then it is washed and then dried and cooled in desiccator, and whatever weight after cooling in desiccator is M2, and the hemicellulose content is M1 minus M2 upon M0, where M0 is the initial dried weight of the sample. So here we have M0 as 3 grams, M1 is 1.6, and M2 is 1.3. So hemicellulose content will be 1.6 minus 1.3 upon 3 into 100, that is 10%. So correct answer is A, 46.66% of extractive content and 10% of hemicellulose content. So we'll move forward. And this is a question based on concept of BOD. The question is, in determining BOD5 of the sample, an analyst added 2 and 5 ml of sample to two different 300 BOD bottles and filled them with seeded dilution water. The analyst also prepared 3 blank bottles with the same dilution water and incubated the set at 20 degrees centigrade for 5 days. DO measurements were made on sample before and after incubation. Actually, the sample number should be 2 because 2 readings are given. So I'm sorry for my mistake. So first is correct, but for blank sample also 2 blanks were prepared and average was taken. So we have we have taken 2 samples. In one we have added 2 milligrams. So sorry, the sample should be in ml. So first we have taken 2 ml of the sample, and in the second we have taken 5 ml of the sample. We have determined the initial DO as 8.1 and 8, and for blank we have determined the initial DO as 8.2. And after 5 days incubating at 20 degrees centigrade, we have find what is the final DO. So I'm sorry, that is my mistake that I forgot to add animation to this. Anyhow, solution is in front of you, so I'll explain it. Like, to determine BOD, what we do is we find the initial DO of the sample and we find the initial DO of the blank. And then after incubating at 20 degrees centigrade for 5 days, we determine what will be the DO of the sample at the end of 5 days and DO of the blank at the end of 5 days into D, where D is the dilution factor. What dilution factor we have applied. So here we can see, we will find what is the BOD for 2 and 5 ml samples. For 2 ml sample, initial DO is 8.1 and final is 5.6. It is 8.1 minus 5.6, and we will determine the initial and final DO for blank, and we will subtract it from the sample into dilution factor. Here the dilution factor will be 300 by 2 because we have used the 300 BOD bottles in which we have added 2 ml of the sample, and rest is our blank, whatever water we are using, maybe distilled water or milky water, whatever it is. So here dilution factor will be 300 upon 2. We will get BOD5 as 345 milligrams per liter. And for 5 ml bottles, similarly, it will be initial DO 8 minus final DO 1.7 minus DO of the blank into dilution factor. Here the dilution factor will be 300 by 5 because 5 ml of sample is used in, and the rest is water. So the BOD5 will come out to be 366 milligrams per liter. And then we can find the average BOD from these two values, and it will be 355.5 milligrams per liter. So hope you have understood it. Are you having any problem in this question? You can ask me, or you can type in the chat box, or you can just tell me that you have understood it. Okay. Then we'll move forward to next question. So next, this is still assignment 2. Then we will solve two questions based on what was there in the tutorial section of incineration. We will try to solve two questions based a similar question based on incineration. So this is the first question. The question is, a dry municipal solid waste has the following composition. It is written in the question itself. It is dry, so moisture content is 0. Carbon is 35% by weight. Hydrogen is 10% by weight. Oxygen is 30% by weight, and ash is 25% by weight. When we will add these four values, then we will get 100%. So we have to determine the molecular formula of the waste. We are given carbon, hydrogen, oxygen, and ash content. We just have to first find what will be the molecular formula of the of the waste. So I will give you 4 minutes to find what will be the molecular formula of the waste. So try to solve this. First, try to solve A part, then we'll move to B part. So I got one answer. We'll wait for 2 more minutes for others to solve. For those who have just joined just now, we have to find just A part, what will be the molecular formula of waste of this composition. Just try to solve the A part of the question. Okay, we'll move to the solution for part A. First, for solving this question, we will assume any weight of the waste. We will take basis as 100 gram of dry municipal solid waste. So suppose we are given 100 grams of MSW. Out of this, 35% is carbon. So weight of carbon is 35 grams, hydrogen is 10%, so it will be 10 gram, oxygen as 30 grams, and ash is 25%, so it will be 25 grams. So first we will find out the number of moles of each element, carbon, hydrogen, oxygen, and ash. So molecular weight of carbon is 12. So number of moles will be 35 divided by 12. That is 2.917 moles. Molecular weight of hydrogen is 1. So it will be 10 by 1, 10 moles. For oxygen, molecular weight is 6. Sorry, atomic weight is 60. Carbon, hydrogen, oxygen, we will take atomic weight because these are the elements. For oxygen, atomic weight is 16. So number of moles will be 30 by 16, 1.875 moles of oxygen. And for ash, it is given that the molecular weight of ash is 56. So number of moles of ash will be 25 upon 56, that is 0.4464. So the molecular formula for MSW will be C2.917, H10, O 1.875, and ash 0.4464. So we have solved the part A. Now we will try to solve part B. From part A, we will get the molecular formula. Then we have to find the amount of oxygen and air required for combustion of this molecular weight, this MSW. So we will do the structure. We will write the equation for combustion of this in presence of oxygen. We will balance the equation. So okay. Only one person has solved it. So Venkateshan, you are right. For B, we will see what is the answer. So what I was telling that we will write the reaction for combustion of this in presence of oxygen. We will balance that reaction and then we will get how many moles of oxygen is required for burning 1 mole of this composition of MSW, and then we will find out what will be the mass of oxygen and what will be the mass of air required. So I have given you the hint. You have the formula for the MSW. You just have to write the reaction for combustion of this in presence of oxygen, balance it, and then you have to find out how much oxygen is required. So try to solve part B. I will give 4 minutes for part B also. So everyone, please try to solve it. So I have not got any response after Venkateshan. So are you guys solving? Should I wait for some more time? Okay. I will give you the chemical reaction, and then you can do the calculations on your own. So since ash is inert, it will not take part in the reaction. So we can remove the ash. So whatever the amount of ash is present in the reactant, same amount will be present in the product. So if G moles of ash is present in the reactant, G moles of ash will be present in the product also. So we can balance here, like this is the composition. If we end products will be carbon dioxide, water and ash, because nothing else is present. If sulfur and nitrogen were also present in the municipal solid waste composition, then there will be two more products, SO2 and NO2, based upon the what is the percentage in the MSW. So we will get end products as CO2 and H2O. So what we have to do is like we have to apply simple mass balance. So for carbon, here composition is 2.917. So in reactants, A is 2.917. So F will also be 2.917, because as we know from mass balance, whatever amount of carbon is present in reactant, the same should be present in the product. So A equals to F. Similarly, we will do mass balance for hydrogen. HB is the amount of hydrogen present in the reactant. Same amount should be present in product. So we will equate B equals to 2E. Similarly, we will equate for oxygen. And for oxygen, it will be C plus 2D equals to E. So I encourage you all to please try to solve it by your own and see what you are getting. So we will write the mass balance for carbon. It is A equals to F. From here we can see A equals to F, B equals to 2E. So for hydrogen, B equals to 2E, and for oxygen, it is C plus 2D equals to E. E plus 2F, because CO2 also has oxygen, so it will be E plus 2F. So E plus 2F. We have these three equations, and we have to find out, we know A, B, C, G, we have to find out what will be D. So what will be the D, F, E are unknown and rest are known. So we have three equation and three unknown. So we can solve it. A equals to F equals to 2.917. Then B equals to 5E. We know the value of B, it is 10. So we will put here B as 10, and we will find out E equals to 10 by 2 equals to 5. Similarly, for C we have C is 1.875. So we will put it in the third equation, C plus 2D equals to E plus 2F. We know what is C. We have already find out what is E. So, and we know what is E, what is C, and what is F. Only unknown is D. We will put the value of C, F, and E in this equation, and we will find out D. D is 4.4975. So from stoichiometry, we can see that for 1 mole of this composition MSW, we need D moles of oxygen. So we have taken the basis as 100 grams of MSW. So we will find out what is the amount of oxygen and air required on the basis of 100 grams MSW only. So we know that 1 mole of MSW requires D moles of oxygen. So we will find out for 100 gram of MSW, oxygen requirement is 4.4975 into 32. That is 143.92 grams. So we will okay. So next we will find out what is the amount of oxygen required per gram of MSW. So we will divide this by 100 and we will get the value as 1.4392 grams of oxygen. So we have done till now. We have found out how much oxygen will be required. But next part is we have to find out what is the stoichiometric requirement of air if the ratio of nitrogen to oxygen in air is 3.76 is to 1 by volume basis. So we will try to solve this part also. That nitrogen to oxygen ratio is 3.76 is to 1. It is given in the question. So each mole of oxygen will be accompanied by 3.76 moles of nitrogen. So nitrogen in the air containing this mole of oxygen equals to 3.6 into moles of oxygen. We will get 16.9106 moles of nitrogen. So we know mass of nitrogen is 28. 14 plus 14, 28. So we will calculate how much mass of nitrogen is required. So it is coming out to be this 473. So we will find out the mass of air. Air is composed of mainly oxygen, nitrogen, and some amount of other gases like CO2, water vapor, and other gases. So we will assume that air is composed only of oxygen and nitrogen in the ratio of 3.76 is to 1. So the total mass of air equals to mass of oxygen. This is 143. And what is the mass of nitrogen? So these two, by adding these two, we will get what is the total mass of air required, which will come out to be 617. And then we can write that for 100 gram of MSW, 617 grams of air is required per 100 grams of MSW. So till now, everyone got this question? Anyone have any doubt on any step? You can ask me now. Because next question is based on this only. First, we have to find out what will be the molecular formula of the MSW. So we can, Mukesh has written no ma'am. So we'll move forward to the next question. Okay. So first part of this question is exactly same what we have done in the previous question. So I want answers from you, all of you, like all of you three, because there are only three participants. I want answer from every one of you. So the question says that our MSW has the following composition on mass basis. The composition of carbon, hydrogen, oxygen, nitrogen, sulfur, chloride, moisture, and ash is given on the mass basis. After adding the percentages of these, we should get 100. So also there is one more statement that assume molecular weight of ash is 56. So we have to find the molecular formula for this MSW. So this MSW has moisture also, and moisture is in the form of H2O, we all know. So we have to find out what will be the formula of this MSW. So I am giving you 5 minutes to solve this question. I want answer from everyone. So please try to solve this question. I'll wait for 5 minutes. So there is one more participant, Rajesh. For Rajesh, we have to solve part A of this question. We have to determine the molecular formula of the MSW. So please try to solve this question. You have to only solve part A now. So only Venkateshan has solved the question. I request you all to please try to solve. I'm giving you 2 more minutes. So we will see how to solve this question. Um, the mass percentage of each element is given. So we will first assume any basis amount of municipal solid waste. Suppose we assume the basis to be 100 grams of MSW. So on the basis of mass composition, we will find out how much grams of each element like carbon, hydrogen, oxygen, nitrogen, ash, moisture is present in the MSW. So this is the table. We have the element carbon, hydrogen, their respective percentages, that there is 35% carbon is present. So we have assumed 100 gram of MSW, so 35 grams of carbon will be present. And molecular weight of carbon is 12 grams per mole. So we will find out the number of carbon as 35 by 12, which will come out to be 2.1967. So please check, maybe my calculation may be wrong. So please check it once. So similarly, we will find for hydrogen, it is 5% on mass basis. So mass of hydrogen in 100 gram of MSW will be 5. Its atomic weight is 1. So we'll get the number of moles of hydrogen as 5. So again, for oxygen, it is 25%. So 25 grams of oxygen. Mass of oxygen is 16 grams per mole. So we will get number of moles as 25 by 16 is 1.5625. Again, for nitrogen, we will find out 0.5%. So 0.5 grams of nitrogen divided by mass of the molar mass of the nitrogen, and we will find out the number of moles of nitrogen. For sulfur also, it is 0.15%, and we know atomic mass of sulfur is 32 grams per mole. So we'll find the number of moles of sulfur as given weight 0.15 grams divided by molar weight 32, and we will find out as 0.0047 number of moles. For chloride, it is 0.55%, so 0.55 grams of 0.55 grams of chloride in 100 grams of MSW divided by its molecular weight. Then we will find out the number of moles of chloride in the paste. Then moisture will be present in the form of H2O. We have 26% of moisture. So out of this, 1 mole of water molecule has 1 mole of oxygen and 2 moles of hydrogen. So first we will find the number of moles of water, 26 gram divided by molecular mass of H2O, that is 18. So we will get 1.4444 number of moles of water. So we know from H2O, oxygen is equal to number of moles of H2O. So it is 1.44, and number of moles of hydrogen is double the number of moles of water. So it will be 2 into 1.44. It is 2.8888. Sorry. And for ash, it is given 7.8%, and molecular weight of ash is given as 56. So we will find out the number of moles of ash as 7.8 divided by 56, that is 0.1393. So we have find out the number of mole of each element. So we have got the what is the molecular formula of the MSW. So it will be C 2.9167, H5O 1.5625, and 0.0357, S 0.0047, chloride 0.0155, moisture 1.44, and ash as 0.1393. So this is the molecular formula. So what we can do in the next step, that water is composed of hydrogen and oxygen. We can add the number of moles of hydrogen and oxygen in water to this number of moles. Like we have already 5 moles of hydrogen, and we will add 2 into 1.444 moles of hydrogen, that will be 7.888. Similarly, for oxygen, we have this much moles of oxygen, and we will add the mole of oxygen from water, which is 1.4444, and we will get oxygen as 3. This. So the overall molecular formula of MSW is this. Now we have solved the part A. Now we will move to part B. Now what we have to do is we have to find the heating value on dry basis and as received basis. So what is the difference between dry basis? That we have to remove the moisture from the MSW, and on as it is basis, like we have to find out how much heating value will be on along with the moisture in the MSW. So for this we will use this formula, that is 0.3516 C plus this much H minus this much O plus this much N plus this much sulfur. What we have to do that we have to take percentage carbon, hydrogen, oxygen, nitrogen and sulfur in the form of percentage by mass. So we have already given the percentage by mass percentage of each element, and we have to put it in the formula, and we have to find out the high heating value on as it is basis, and then for finding on the dry basis we will find the mass percentages after subtracting the water content from MSW. So I will again give you 3 minutes to solve the HHV on as received basis, because it is pretty straightforward. You just have to put the percentage of carbon, hydrogen, oxygen, nitrogen and sulfur in this formula, and you just have to calculate what will be the HHV. So I am giving you 3 minutes to solve second part of part B, that what will be the heating value as received basis of the MSW. So please try to solve it and just write your answer in the chat box. If anyone have any doubt, you can ask anytime. So I'll wait for 3 minutes. So I can see only one answer. So we'll move to part B. Now we have to find out high heating value on dry basis. For dry basis, we will find out composition of each element by removing the amount of moisture content present in MSW. So we can see that 26% of moisture is present. So we will remove this from the total MSW amount. We have taken 100 gram as basis. So we will remove 26 gram of water. So what we will get is 100 minus 26 is 74 grams of MSW, dry MSW. So by using this 74 grams of MSW, we will find out how much carbon, hydrogen and other elements are present. So what we will do is we will find out the composition of MSW on dry basis. We will find out how much mass percentage of carbon is present and other elements is present, and then we will put it in this question. So for carbon, what we will do is 35% is present in 100 grams. So what we will do is now we have to find doing 74 grams because 100 grams of MSW minus 26 grams of water will be 74. So we will find out as carbon is 35 divided by 74 into 100. Whatever percentage we will get, it will be for carbon, and we will calculate for all the elements. So again, I am giving you 3 minutes to find out the percentages of these elements and put these and then put the percentages of each element in this formula and find the HHV on dry MSW basis. So please try to solve. So only one person is solving the questions. I request you all, if you have not gone through the lectures, please go through week 2 material and then try to solve this question. There is also one video on tutorial of these questions. I have taken similar questions so that you can revise it. But since you all are not solving, so I assume you have not gone through the lectures. So I request you all to just go through it and then try to solve these questions. So I will give you the solution. So we have already found out what is the molecular formula of the MSW on as it is basis. We have also considered the moisture. Now we have to find out the high heating value on dry basis. So what we will do is we will subtract the amount of moisture in MSW. We have taken 100 gram of MSW as the basis and 26% is moisture. So 26 gram in 100 gram is moisture. So whatever is whatever we will get is MSW mass on dry basis, that is 100 minus 26 give 74 grams. So what we will do now is we will calculate the mass composition of MSW on dry basis. We have these percentages on as it is basis. Now we will modify these percentages for dry basis. We have 35% on as it is basis divided by, we have 35%, that is 35 grams of carbon, divided by total dry weight of MSW, that is 74, and for percentage we will multiply by 100 and we will get 47.29 whatever it is percentage of carbon on dry basis. Similarly, we will do for hydrogen. We have 5%, that is 5 grams in 100 grams on as it is basis divided by the mass of dry weight into 100. We will get the percentage of hydrogen. Similarly, we will do for oxygen, 25%, that is 25 grams into 100 divided by 74. We will get the percentage of oxygen on dry basis. Similarly, we will do for nitrogen, 0.5 is given, 0.5 by 74 into 100, this much percentage of nitrogen. For sulfur also, 0.15 is given, so 0.15 divided by 74, this much of sulfur. For chloride also, 0.55% chloride is present. It is on as it is basis including the moisture, so we'll remove the moisture to find on dry weight basis. 0.55 divided by dry weight of MSW, that is 74 into 100, we will get this much percentage of chloride. And for ash, it is 7.8%, so 7.8 grams of ash divided by MSW, dry MSW weight divided by 74, that is 10.54%. So we have calculated the percentages on dry basis. In the question, the percentages are given on as it is basis. So we have to find the HHV on dry basis and HHV on percentage basis. So we have this formula. We will put the percentage of each element in the formula and we will get the HHV in megajoule per kg. So we will find for on dry basis first. We have this form 0.351C into the percentage of carbon, then percentage of hydrogen minus this much into percentage of oxygen plus sulfur plus nitrogen, or plus nitrogen plus sulfur. So after putting, we will get this much value, and for as it is basis, we will put the percentage composition as given in the question. That is 35% carbon, 5% hydrogen, 25% oxygen, 0.5% nitrogen, and 15% sulfur. We will solve it and we will get the HHV value. So Venkateshan is getting different value. So Venkateshan, you cross-check your calculation. There may be a possibility that I have done this calculations. I have done some calculation mistake. So you cross-check both these and you will get the right answer. So in these questions, like we have given the MSW composition, we have to find the formula. For this, we just have to find the number of moles of each element and then we can get the molecular formula of the MSW. Now we have got the molecular formula. We have to find how much air or oxygen is required. So simply we have to write the combustion equation. that we have to write the formula of MSW, then we have to react with oxygen, and the final product will depend upon the composition. If there is carbon, final product will be CO2. If there is nitrogen, final will be NO2. If there is sulfur, we will get SO2. If there is hydrogen, oxygen, obviously it will be present, then we'll get water and we will get heat. So we will write the equation, we will write the chemical reaction for combustion of the waste, and then we will try to balance it using the mass balance of each element. So the number of moles of each element in the reactant side should be equal to number of moles of that element in the product side. By equating each element on the reactant and product side, we will get some like whatever the number of equations we will get. Out of that equation, some will be omitted, some will be known because we know the composition of MSW. So few values will be known and we have to find the unknowns. So we can solve these equations simultaneously and we can get the unknowns. Now we know the balanced reaction for municipal solid waste burning. So we can calculate how much oxygen is required. And using that, we can calculate how much air will be required because we know that how much percentage of nitrogen and oxygen is present in the air. So we will find the ratio of that, and then we can find how much nitrogen will be used. And then we can add the mass of oxygen and nitrogen, and we will get the total mass of air required. And this was all about question 1. Sorry. Now for question 2. First part of question 2 is similar to the previous one. We have to find the molecular formula. We have all the elements percentages on mass basis. What we will do is we will take any basis and we will find out how many moles of each element is present. Like we have find the moles of carbon, hydrogen, nitrogen, oxygen, chloride, whatever is present in the waste. We find the number of moles. So we got the what will be the molecular formula of the waste. So if we got the molecular formula, again, if in this question it was asked what will be the amount of oxygen required for burning it, or what will be the amount of air required for combustion or burning of the waste, then again we will write the balanced reaction for balanced reaction for combustion of the waste in presence of oxygen. We will balance it by equating the mass balance of each element. Then we will find out the stoichiometric coefficient of oxygen and other products form, and using the and using how much for 1 mole of MSW, what is the amount of oxygen required, we will find the amount of oxygen. If it is asked what will be air required, then we will find what will be the amount of nitrogen required. We will add these, we will get the amount of air required. And for finding the heating value, the formula is given here. We have to use this one. The only thing is that CHONS are used on percentage basis, mass percentage basis. So the two things was asked. We have to find on HHV on dry basis and on as received basis. So for dry basis, what we will do, we will find the percentage of each element on the basis of dry basis. For that, we will subtract the amount of moisture content from the from the MSW. We will get the dry mass of MSW. So we have the total mass of MSW, and we have composition of these. So percentages of these. So we will find out how much percentage of carbon will be on the basis of dry mass. So we will divide the given mass, that is 35%, so 35 grams, divided by total mass of MSW on dry basis, that is 74, and we will get the number of moles. So after getting, we will get the mass percentages of these. There is no requirement to find the number of moles. So we will calculate each element's mass percentages on the basis of dry basis. Then what we is next is we just have to put these percentages in the formula. Like this is 0.315 C plus this. We just have to put the percentage in the formula and we will get the value. So hope everyone got this. Anyone have any doubt from my first slide till now? if you have any doubt, any question related to the lecture or related to assignment questions which I have discussed or tutorial question, you can ask me. Also, I encourage you all to please join the session on Saturday and Sunday. On Saturday, it is from 3 to 5 p.m. and on Sunday, it is from 7 to 9 p.m. And also, I request you all to please join on time because today many students were joining after 7:15, 7:30. So you may skip some part if you are late. So from next time, try to join on time. And if you have any question, you can ask me or you can ask on Saturday or you can ask on the discussion forum on the NPTEL portal also. And one more thing, one person has asked in the previous session that what is the stats for MSW generation in India. So I would like to answer that question that since that person is not present, but still I would like to give you the answer that the amount of MSW generated in India depend upon how is the population of that city. So MSW generation is in India ranges from 0.2 to 0.6 kg per capita per day if the population range is between 1 lakh to 50 lakh. So it will depend how much people are residing in that city, and on basis of that MSW generation will depend. Also, I have told in the last previous session that there is a trend that with increase in income, like we are going from developing to developed, we are on the path of going from low income to developing, and then we are proceeding to a developed country. So slowly our GDP will increase. With increase in GDP, our municipal solid waste production will also increase. So every year there is a trend that there is 1.3% increase in the MSW generation. So you can also go to the website of Ministry of Urban Affairs and you can get these stats about how much MSW is generated in India on every city basis, on an every state basis. So I would like to end this session here. If anyone have any question, you can ask me, or I will end the session here. Okay. Also, I will request you once again to please join on Saturday, on Sunday, and please be on time. So I think no one have any questions. So shall I stop here? So, okay, thank you so much for joining and thank you. Thank you so much. Good night.